Assalamualaikum and good day to all. So we will start our first online lecture on Thermodynamics learning unit, and we will discuss these terms here in this learning unit, which are heat, work, energy, heat capacity, enthalpy, and the detail will be in the following slides. Now the learning objectives expected from each and every one of you that you should be able to accomplish are: firstly, distinguish between system and surrounding, and secondly, defining zeroth law of thermodynamics, thirdly, solving problems associated with heat, work and internal energy. Next is relating enthalpy and internal energy. So what is thermodynamics? So thermodynamics is actually science of heat and temperature. Okay, so in particular, it governs the conversion of energy change, okay, when a reaction occur. Okay, for example, from thermal energy into mechanical or electrical or other form of energy. Okay, and it deals with energy conversion. Okay, like I mentioned just now, from one form to another. Secondly is stability of molecules and the direction of change. So during a reaction, what happened to the molecules, and how about the direction of change? So our focus in thermodynamics is to predict, okay, and also the direction of the extent of chemical reaction, okay, but not about the rate. Okay, rate you have covered it in kinetics. Okay, so thermodynamics allow us to predict, okay, the direction and also extent of chemical reaction. So our concern or our focus will be only on chemical thermodynamics. So thermodynamics is very broad. Okay, so we only focus on chemical thermodynamics. So these are the questions that we should address, okay, when we study chemical thermodynamics. How much heat is evolved when a chemical reaction occur? What determine the direction of the chemical change? Is it spontaneous or is it non-spontaneous? Okay, what determine the extent of chemical change? Okay, so what are the factor? Okay, in this case, next is the position of the chemical equilibrium. Okay, once the chemical reaction occur, does it lies more toward the product side or the reactant side? So we look at the position. Okay. Okay, next is system and surrounding. So what is system? System is the object of interest, means where the reaction takes place. Okay, let's say this is the reaction vessel. So therefore this is the system. Surrounding is the rest of the universe, okay, that surround the system. Now energy can flow between the system and the surrounding, means the energy from the system here can flow to the surrounding, and also energy from the surrounding can flow into the system. Okay, so system is classified into three types. Okay, the first type is open system. Open system means matter and energy can enter and leave. So let's say you have that reaction vessel, okay, and you have reactants, okay, reactant A and B react together, so that is matter. Okay, you can still add in matter during the reaction, that's why it's an open system. Energy also can enter and leave. Okay, second type is closed system. Closed system means the reaction vessel is closed. Once you put the reactant, then you close the reaction vessel. So therefore, matter can no longer enter or leave. However, energy can enter and also leave. Okay, enter the system from the surrounding and also leave from the system to the surrounding. Now, the third type of system is isolated. Isolated means neither matter nor energy can enter or leave. Okay, in this case, you have a very good reaction vessel. Okay, uh, once you put matter inside, that matter cannot reactant. Okay, the reactant, it cannot leave the reaction vessel. Energy also cannot leave or enter. Okay, a good example of isolated is bomb calorimeter. Okay, uh, a good example of closed system is flask. Okay, you put hot water inside a flask. Okay, um, means matter can no longer enter once you close the flask. However, energy can enter and leave. Okay, when you put the hot water inside, after like 8 hours or 10 hours, somehow the water will cool down. Means energy already leave the system to the surrounding. Okay. Now there are two type of concept, okay, relating system and surrounding. The first one is diatomic. Okay, diatomic. So diatomic system, it allows energy to escape as heat. Okay, energy can escape as heat through boundary. Okay, if there is a difference in temperature. So means when you put solid ice, okay, you take out solid ice from your freezer and put it on the table. Okay, after some time the ice will melt because energy escape as heat through boundary because they are different temperature. Okay, the surrounding and the ice itself. Okay, that is diatomic. Second type is adiabatic system. Okay, adiabatic system, it does not permit the energy to escape as heat. Okay, through boundary between the system and the surrounding, although they are different, they have different in temperature. Okay, example like I've given just now, bomb calorimeter. Okay, now I'm sure you're very familiar with endothermic reactions. So what is endothermic reaction? Means a system absorb heat from the surrounding. Okay, so that is endothermic. Okay, so some chemical reactions are endothermic. Okay, some are not. Okay, example of endothermic reaction, this is very general one: melting. Okay, absorb heat from the surrounding. Vaporization. Okay, sublimation. Okay, this is change from solid directly to gas. So that is endothermic. Next is exothermic. If endothermic absorb heat, exothermic on the other hand will release heat, okay, from the system to the surrounding. So there are also chemical reactions. They are exothermic. Example, which are general example of exothermic reaction, include freezing, okay, condensation, deposition. So if you want to freeze water, you have to remove heat, okay, heat from the water in order to freeze the water into ice. Next is zeroth law of thermodynamics. Now, what is zeroth law? Okay, let's say you have object A here. Okay, so this object A is in thermal equilibrium with object B. So means both are same temperature. Okay, thermal equilibrium. Object B is in thermal equilibrium with object C. Okay, B and C same temperature. So what we can conclude here, okay, object C should also be in thermal equilibrium with object A. So that is zeroth law of thermodynamics. So the zeroth law of thermodynamics, it deals with the nature of thermal equilibrium when two systems are brought to thermal contact. Okay, and this is why thermometer is developed. Okay, when you put thermometer under your armpit, under your tongue, okay, it measure the temperature of your body. Okay, because it brought thermal equilibrium between your body and the thermometer. Okay, next we move on to the first law of thermodynamics. Okay, so what is the first law of thermodynamics? Okay, we have covered zeroth law. Next is first law. So first law actually is law of conservation of matter or energy. Now what does it mean by law of conservation? Means energy cannot be created or destroyed, but it can be converted from one form into another. Okay, you cannot destroy or create energy. Okay, for example, you climb up stairs at the swimming pool, then you jump into the swimming pool. So the moment before you jump into the swimming pool, okay, what is your energy at that point? Potential energy. Then once you jump into the swimming pool, that potential energy converted into kinetic. Okay, the motion of you jump. Okay, movement from the top of the ladder into the swimming pool. Okay, once you reach the pool, some of your kinetic energy will be converted into heat. Okay, now the total energy of an isolated system, remember you have three types of system just now. The total energy of an isolated system is constant. For non-isolated system means open or closed, energy is lost, okay, in the form of heat. Its surrounding will gain the similar amount of energy that is lost. Okay. Now, according to first law of thermodynamics, we can write this relationship here. Okay. The change of energy of the universe will be equivalent to the sum of change of energy of the system and change of energy of the surrounding. Okay, when we say total energy is constant, means zero. Okay, for universe, zero. So therefore, change of energy, energy of the system and energy of the surrounding change will be equivalent to zero. So therefore, we rearrange this expression. Okay, the change of the energy of the system will be the opposite of the change of the energy of the surrounding. Okay, not sign here. Okay, one will be positive, the other one would be negative.
So these are the basic concepts that everyone must know. The first one is work. Work is mechanical transfer of energy. For example, gas expanding. Okay, so that is example of mechanical transfer of energy. Second is energy. What is energy? Energy is a capacity of a system to do work or to transfer heat. And what is heat? Heat is a form of energy that is transferred from one system to another system or surrounding. Okay, so this will only occur if there's a difference in terms of temperature. For example, transfer of heat from a hotter object to a colder object. Now, how do we relate heat, work, and internal energy? Okay, to be specific, internal energy. Okay, so change in the internal energy. If you see this symbol here, triangle symbol, it means change. So change in the internal energy of a closed system will be equivalent to the energy that passed through boundary as heat or work. So internal energy change will be equivalent to the sum of change of heat and change of work. If the internal energy value is negative, means less than 0, it means that the system loses heat. And in terms of work, it is doing work on the surrounding. Okay, system doing work on the surrounding. However, if the internal energy is a positive value, means more than 0, the system gain heat. Okay, and the surrounding is doing work on the system. Okay, work is defined as applying a force over distance. So if you recall from physics subject that you have learned before, work W, okay, will be equivalent to distance times force. Okay, and force is equivalent to mass times acceleration. Okay, mass times acceleration, and this acceleration, okay, is considered gravitational force. Okay, in this case will be 9.81 meter per second. So important type of work in chemistry would be expansion work. Now, next we move on to expansion of work. Let's say you have a piston here, okay, and external pressure is applied, okay, pushing down the piston. Okay, so when you push down the piston, the air or gas inside here, okay, will be swept out. Okay, so let's say the piston is pushed from this point to this point here, so there will be a change in terms of volume from this point to this point here. Okay, so this external pressure P(Ex) equivalent to the weight pressing on the piston. Okay, and a force opposing the expansion is equivalent to F. Okay, is F equivalent to external pressure times area. Okay, the area of the piston. So work would be equivalent to external pressure times area times D. Okay, so area times D would give you volume. It's like you have length times width times height, and you get volume. Okay, so you see there's a triangle symbol here. It means change in the volume. Okay, the movement of the piston just now. So when a system expands against a constant external pressure, the work will be done by the system. Okay, so this is the formula. Okay, the formula is work, okay, equivalent negative external pressure times change in volume. Okay, now what does this the meaning of this minus sign here. Okay, if an expansion of work, okay, means expanding, okay, gas expansion, final distance will be higher in terms of volume compared to the initial distance. So therefore, W would be negative. Okay, would be negative. When W is negative, it means work is done by the system. That is expansion. In the earlier slide, there is example of compression. Okay, piston is pushed down. So when the piston is pushed down, work is done on the system. So therefore, the initial distance would be bigger, higher compared to the final distance. Okay, so you get a positive sign. Okay, here positive. And W, of course, will be measured in joule. Now let us look at expansion against constant pressure. Okay, so this is constant pressure here. Okay, so work is done by a gas. So you have gas, okay, in this piston here. Okay, so it's expand. This is the original position. Then you expand to V2. Okay, so this expansion from this point is against the external pressure outside. Okay, and that will be equivalent to this shaded area. Okay, the work done will be equivalent to this shaded area. Okay, so how to find work? External pressure times change in the volume. So total work done in that expansion from position V1 to V2. Okay, so we integrate the formula W equivalent to negative PXV. So integrate, so you get this. Okay, negative PEX volume 2 minus volume 1. Okay, so if the change in the volume is equivalent to 0, means the work is being done. Okay, 0 times any value will give you 0, so no work is done.